Hello friends, in the first lecture of inverse trigonometry, I explained you how do we find the inverse trigonometric functions and what is the principal domain of those trigonometric functions where we find the inverse of these functions, and the graphs of the sine inverse and cos inverse of x, domain of sine inverse x and cos inverse of x. So now I'm going to teach you rest of the things of the inverse trigonometry, so that today you can solve the first exercise of your NCERT textbook. So the principal domain which I explained in the first lecture, where we study the inverse of these trigonometric functions. For the sin x I told you is minus pi by 2 to plus pi by 2. Close interval, and for the cos of x it is 0 to pi. For tan of x it is open interval minus pi by 2 to plus pi by 2. For cot of x it is open interval 0 to pi. So this I have already explained in the first lecture, that the sin x and cos x inverse, how do we find, and what is the domain and range of sine inverse of x and cos inverse of x. So quickly I'll tell you for the sine inverse of x. So since the principal domain for the sine of x is minus pi by 2 to plus pi by 2, so it means the sine inverse x's range will be there, and the domain is this domain is minus 1 to plus 1, and range is minus pi by 2 to plus pi by 2. Means any answer of the sine inverse of x can never be greater than pi by 2, nor it can be less than minus pi by 2. And for the cos inverse of x, domain is again minus 1 to plus 1, because the answers, if I keep 0 to pi for the cos of x, you see the cos x graph is from 0 to pi is like this. I've already explained this thing, you can check the lecture 1. So you are getting all the values between 1 to minus 1. So the answers which you get in the cos of x will become the domain of the cos inverse of x, and the range you get is, this is a domain and the range is minus 0 to pi. This is a range. So now for the tan inverse of x. So for the tan inverse of x, the principal domain we have taken minus pi by 2 to plus pi by 2, and you know all the answers of the real numbers you get from minus pi by 2 to plus pi by 2 for the tan of x. So domain for the tan inverse of x is all real, because the answers which you get from tan of x all real, and the range is open interval minus pi by 2 to plus pi by 2. And similarly for the cot inverse of x, domain is all real and the range is 0 to pi open interval. So I think this is clear now. I'll come to for the sec x and cosec x also. So now for the cosec x and sec x, for the cosec x, the principal domain is minus pi by 2 to plus pi by 2 except 0. Why we have deleted 0 there? Because we know the cosecant x is a reciprocal of sin x, and sin 0 is 0, and that reciprocal will become infinite. That's why we have excluded 0 there. And similarly sec x is 0 to pi except minus pi by 2, because cos is 0 at pi by 2. And you also know the range of these two you get is minus infinity to minus 1 union 1 to infinity. So when I'm going to find the inverse of cosecant x and sec x, the answers which we get from the cosecant x and sec x will become the domain for the cosecant inverse of x and sec inverse of x. So for cosec inverse of x, the domain is minus infinity to minus 1 union 1 to infinity, and range is this minus pi by 2 to plus pi by 2, close interval, minus 0. This is the input of the principal domain for the cosecant x, that's why it has become the range over here. And similarly, for the sec inverse of x, domain is minus infinity to minus 1 union 1 to infinity, and the range is 0 to pi minus pi by 2. So after covering this the board portion, when I'll be dealing the mains and advanced portion, and that time I'll tell you how to plot these graphs of the sec inverse x and cosecant inverse x also. As of now, I'm just dealing this portion of the principal domain so that you can solve the problems of the exercise 2.1. So this is what we have understood. What is the domain of sec inverse, sine inverse, cos inverse, sec inverse, tan inverse and cot inverse, and what are the corresponding ranges. So this is what we know now, okay? Now, we have done the composite functions in the functions chapter. So let's say you are asked what is the f inverse of f of x. So what does it mean? See, it's quite easy to understand. Let's say in fx, I write alpha as an input and the corresponding answer I get beta. This is what I am getting in fx. And what happens the inverse of fx? Means if I am getting beta from alpha, so what will happen in the inverse of that? In f inverse of x, if I write beta as an input, then I will get alpha as an output. So what will happen? I will start here with alpha, means this x I will replace by alpha. So if I replace this x by alpha, what the answer you will get? What the f of alpha will be? F of alpha will be beta, isn't it? And then once you get, and when you substitute beta in the inverse, you get the answer alpha. So if I write beta there, I'll get alpha. So what happens, you see, in f inverse of fx, you started the value of x is equals to alpha, and finally from here you are also getting the answer alpha. Means whatever the input you will write here, the same answer you will be getting in f inverse of f of x. I hope this point is clear to you. So before I start this exercise 2.1, the first exercise, one thing I'll tell you, see, let's say sine inverse of sine of x is there. So as per the f inverse of f of x, I must get the answer x, so here I will also get the answer x. Clear? And we also know the answers of the sine inverse of x remains from including minus pi by 2 and plus pi by 2, means the range of sine inverse of x minus pi by 2 to plus pi by 2. means I cannot have answer more than pi by 2, nor I can have answer less than minus pi by 2. So what will happen here? As long as I'm putting the x value from minus pi by 2 to plus pi by 2, there is no problem. I'll get the whatever the input I write, I'll get the same answer. Let's say I replace sine inverse of this sine of x I'm replacing by pi by 3. So very easy to understand, you will get the pi by 3, you can verify it also. I wrote pi by 3 and sine pi by 3's answer is root 3 by 2. So I'll get sine inverse of root 3 by 2, and the sine inverse of root 3 by 2 is basically pi by 3. Is it clear too? But what happens, and one more point here. We know that the sine inverse is defined for all the values which are between minus 1 to plus 1. Means the domain of sine inverse of x is from minus 1 to plus 1. So are we writing those values there? Absolutely, we are writing all the values between minus 1 to plus 1. Any value of the sine of x can never be greater than 1, nor it can be less than minus 1. This is what we already know. But what will happen if I increase the value of x more than 90 degree? Let's say I want to write x is equals to 100 degree. I'm just taking one example there. So, sine inverse of sine 100 degree must be 100 degree as per this rule. But we also know the range of sine inverse is minus pi by 2 to plus pi by 2. Means if the sine inverse x is the sine inverse is the outer operator there, means is the final operator. You started with the x, you wrote here x is 100 degree, I'm writing here. We got sine 100 degree. Whatever the answers I will get, that will remain between minus 1 to plus 1, and I can find the inverse of that. But using this definition, I have to write basically 100 degree. But using here, I know that the answer can never be greater than pi by 2. Means I cannot have any answer which is more than 90 degree, I cannot accept it. So what we will do in that case? See, all the values of sine theta between minus pi by 2 to plus pi by 2, which you are getting from minus 1 to plus, the answers which you are getting is minus 1 to plus 1. Anywhere you go, any value of theta you find there, but the same value of theta can be written in that form so that it remains between minus 90 degree to plus 90 degree. So what I will do there, I will not write as 100 degree. I will convert this. How? I know the sine of 100 degree is equals to sine of 80 degree. Clear? So why I am writing this? You know that sine of theta is equals to sine of pi minus theta. Before when you go for the inverse trigonometrics, it is advisable to go and just go through the identities of those class 11 trigonometric identities. So you can see sine 100 is equals to sine 80 degree. So though I am writing 100 degree, which you are asked to write the 100 degree, but don't write 100 because you know the sine 100's value is equals to sine 80 degrees value. So what the changes I will be doing, I will not write 100 degree there. Rather I will convert this 100 degree as 80 degree. So you are asked to substitute this one. So before operating this f inverse of f of x, immediately you convert that and write the sine inverse of sine 80 degree. Because I know these two values are same, sine 80 degree and sine 100 degree. And I will write the answer 100 degree, which is less than 90 degree and it is acceptable. So now when I am going to handle the problems like this, the principal domain which we are going to handle, the only thing which you have to remember, your answers of all these numbers must remain between the prescribed range of those trigonometric functions, inverse trigonometric function. Exercise 2.1, few of the problems I have taken. Question number 1 is sine inverse of minus half. So now it's very easy, you will find it out which value of sine theta gives minus half. So it is first question, sine inverse of minus half. So let's say the answer we get is theta, because the answers of sine inverse means the angles you will be getting there. So minus half is equals to sine theta. So now we'll see which theta between minus 90 degree to plus 90 degree is equals to minus half. So we know that theta is equals to minus pi by 6. We know that sine minus pi by 6 is equal to minus half. So the answer is minus half. So your answer is basically minus pi by 6, not the half. Theta's value is minus pi by 6. Then the second question is cos inverse of root 3 by 2. Let's say is equals to theta. So cos theta is equals to root 3 by 2. So which value of theta gives the cos theta root 3 by 2, and importantly remains between 0 to pi. So you know theta is equals to pi by 6. So the answer is pi by 6. Next question is tan inverse of minus root 3. Let's say equals to theta. So tan theta is equals to minus root 3. So minus root 3 you will get at minus pi by 3. So theta is equals to minus pi by 3, as simple as that. And similarly you can solve the sec inverse of 2 by root 3. So when sec theta is 2 by root 3, sec inverse 2 by root 3 is equals to theta. So we can write sec theta is equals to 2 by root 3. Sec theta 2 by root 3 means cos theta root 3 by 2. We have just done. You can see these two other will give the same answer there. I will be explaining this thing also. That cos inverse of x can be written as a sec inverse of 1 by x. So sec theta is equals to 2 by root 3. That means theta has to be pi by 6. And the last one is cosecant inverse of minus root 2. Minus root 2. Let's say equals to theta. So cosecant theta is equals to minus root 2. Cosecant theta minus root 2 or sin theta minus 1 by root 2. So theta is equals to minus pi by 4. Clear? So you don't write, you will number of values you will get where cosecant theta's answer is minus root 2. But you have to get the answers between the principal domain which we have derived, which we have taken in the beginning, where we are going to study the inverse trigonometric functions. The inverse of these trigonometric functions we are studying in a certain domain, and which that domain is called the principal domain. So make sure your answer remains between those principal domains for the inverse trigonometric. So theta is equals to minus 4 is this, the answer of this one. So now two more questions from the exercise 2.1. Question 13 is that if sine inverse of x is equals to y, then four options are given, that y is greater than equals to 0 but less than equals to pi. So basically they are talking about the y, and y is what? The answers which you get from sine inverse of x. So I already explained you the sine inverse x's range is minus pi by 2 to plus pi by 2, where both these pi by 2 and minus pi by 2 are included. Okay, so there you can see the difference in the D and B option is that the pi by 2 and minus pi by 2 are not included. So the B option is the correct answer here. And this question number 14, you see the last problem of exercise 2.1, tan inverse of root 3 minus sec inverse of minus 2. So tan inverse of root 3's value you know is pi by 3 minus sec inverse of minus 2. Now sec inverse of minus 2. See, now we'll write sec inverse of minus 2 is equals to theta, right? So we can write sec theta is equals to minus 2. Clear? And we know sec theta is a reciprocal of cos theta. Or we can write cos theta is equals to minus half. Clear? So now you have to write the answer of cos theta, which remains between 0 to pi and gives the answer minus half. So we know in the second quadrant the cos values are negative. In the second quadrant cos values are negative. And what values we are taking, what the answers we are getting for the cos? From 0 to pi. 0 to pi the answers we get for the cos, right? So what we will do here, we can write cos pi minus theta is equals to minus cos theta. Clear? So if I write theta is equals to pi by 3, I'll get minus cos pi by 3. Here I will also write pi by 3. We get cos pi minus pi by 3, which is 2 pi by 3. So cos 2 pi by 3 will give the answer minus cos pi by 3, which is minus half. Okay. So cos theta equals to minus half, or sec theta is equals to minus 2. So theta has to be 2 pi by 3. Is it clear? See, very simple thing you have to remember. You will get the infinite many values of theta where the answers you get minus 2. But you have to write that theta which remains in the range of sec inverse of x, which is 0 to pi excluding minus pi by 2. So the answer which I will get here is 2 pi by 3. So pi by 3 minus 2 pi by 3, and the answer is minus pi by 3. So B option is correct. So this is the exercise 2.1 we have done. Now I'll be taking the exercise 2.2, and before that few of the properties of the inverse trigonometric functions which I'll be explaining you in the next lecture. Bye bye.